short to see the slide. So anyway, my name is Chris Davis. I'm VP of Smart Cities at CIMCON Lighting, and we don't do lighting. It's an old name, and we're going to change that hopefully very soon. If you look at what Curtis said and Frank, and I've known Frank for quite a while now, it's really all about the data, right? And which way do I go here? The far right. Oh, the far right, okay. Can't read it because I don't have my glasses on. It's really all about, getting data, and cities, if they're going to become smart, they have a lot of assets that are deployed across the urban landscape. Many of them are dumb, and cities want to gather data from those and instrument them. So I'm going to talk about an approach that we're working on to gather data from that urban landscape and hopefully provide some added value to platforms and initiatives like at Urbanova. I'm going to skip through these next couple of slides because this has been covered pretty much on what a smart city is. We all know this. Cities really have to provide a variety of services, and the problem that they face is where do they start and what is the business case? And if you look at cities, they're encumbered by higher capital and operating costs, lower tax bases, more senior citizens, a lot of people moving in, congestion, things like that. So it's really hard for them to sometimes afford these services that they'd like to be able to provide, like lighting and parking management and traffic and air quality monitoring, and et cetera. So it's generally recognized that among us smart city practitioners, and many of us are here, that smart and connected lighting is really the first step. And I'd like to focus a little bit on this slide. Unfortunately, cities and utilities often focus on the capital cost of a project. What's it going to cost me up front? And they don't really think about the long-term cost. And what typically happens is that if you look at high-performance building, city infrastructure projects, only about 20% of the life cycle cost are on the front end, so buying the equipment, financing, engineering, design, et cetera. About 80% is on the OpEx side, and that's energy, repair, maintenance, and operation. So I think it's important that cities, as they make this transition to smart, they really need to focus on that 80% OpEx, which is the much larger component. By the way, I was at Schneider Electric for a number of years. I stole it from them. We developed this for the buildings business, but it holds true in outdoor lighting also. So without going into a lot of detail, if you put in smart and connected lighting, the numbers generally recognized by all of us in this space is that if you put in LEDs, on the energy spend, you save about 50 to 70%. Most cities, their energy spend for outdoor lighting is about 40% of the overall total. So that's fairly significant. If you add smart controls, you can save another 10, 20, 30%, depending upon the policies that you use to brighten and dim. There's a huge sustainability impact in terms of carbon reduction because you're using less energy. And from the utilities' point of view, they really, even though they're getting less revenue, they have a better ability to control the demand. And so it can actually help them in terms of the supply side, in terms of being able to better manage that, particularly when they're integrating renewables into the mix. Today, if you have a street light that's out, most cities and utilities take 2.6 truck rolls to fix that light. One to diagnosis or to confirm that the old lady who complained about the light being out is right. Second trip back to the pole is to, okay, we're going to diagnose it, and I don't have the right tools or parts, so they make a third trip. So the average is about 2.6. And if it's on a busy thoroughfare, you've got a detail. So just to visit the pole, to do hardly nothing, is about $80 to $120 a visit, depending on what it is. So we think that if you put smart and connected lighting in, where you've got remote health and diagnostics at that luminaire and it's being communicated back to cloud or enterprise-based applications, you can get that down to one truck roll. So it's really quite significant. So there's a real strong ROI. There's obviously the public safety side. I've got better quality lighting, and then quality of life, economic development, et cetera. won't go into the detail on this, but this sort of explains how these applications work with respect to maintenance, and these slides will be available after the conference. But it's really all about automation, data, connectivity, and producing work orders so that the city workers or the utility people or whoever maintains the street lights can go out and fix that in one truck roll. What's really interesting is that if you look at that 80%, there are a lot of other mobile applications you can develop once you have these smart and connected lighting infrastructures in place. And again, it's all about using data, and I'd like to describe a couple of them very quickly. This is an application we developed at the suggestion of a university in Pennsylvania. They were deploying across their campus these blue button public safety kiosks. People have seen those around, right? What really surprised us is that the cost, the CapEx, not including the OpEx, but the CapEx to install each one of those was $35,000 to $40,000. When you look at design, engineering, trenching, construction, putting the concrete pad in, putting the capital cost. And they said, and we don't get the granularity one, so what can you do with respect to a smartphone app if we put in your smart and connected outdoor lighting? We've got this mesh network in place. So we developed a smartphone app we call the Campus Safety or the Blue Button app. And the whole idea is that the student loads this app on the phone, and if they feel like they're in danger, they can either push the button on the app, or if they can't get to it because they've got a cover on the phone, they just shake it vigorously 3 times. The app talks to the cloud-based application over a cellular network, as you can see here. We know where the student is because they've got a GPS in this phone. We also know where the nearby lights are because they have GPSs in the controllers. So in a 150-yard, 150-meter geofence, we can turn on the lights, brighten them, flash them, and also dispatch campus police to that location. So here we can now provide for the campus total security without a big CapEx, much better granular coverage, and they can use it as a marketing tool to attract more students. And if they wanted to, they could realize revenue from it. Okay, we'll charge you $5. You know, remember those tuition and extra fees you had when you were in college, that $5 here? Okay, so $10 a quarter. So it's a potential revenue source. Yeah. But that's their call. And again, this was just a smartphone app taking advantage of what was already there. We described this application to a police department north of Boston, and they said, well, hey, this is pretty cool. Why don't we, can we use this for first responder apps? So if a policeman makes a traffic stop and you have the lights that are controlled, if I pull somebody over, can I bring them up to their fullest brightness? Usually LEDs are dim 20, 30%, that's bright enough. But can we bring it up to full brightness so as I approach the car, I can get a better look and see if there's a bad guy in that car? That also sort of segued into some additional IP saying, well, if we have true first responders on the site of an accident, can I bring the lights up to their highest level so they have a better look and they can work at, in this crash site? So again, all enabled by smart and connected outdoor lighting. So again, these are some smart city application. It's all about how do you get data from the urban landscape. We worked with Pacific Gas and Electric to develop with them a revenue-grade power meter that does a couple things. One, it monitors the energy consumption of smart cells. These are more granular, smaller cell towers that they put on streetlight poles, and also EV charging stations. And so these are deployed out in Silicon Valley and through their service area, and they happen to run on a Silver Spring network, another smart grid network that we support. So here you see a smart pole in Santa Clara, San Jose area. There are over 250 deployed. Most of them are around the 49ers stadium in Santa Clara, Levi Stadium. So, when people go to a game, there's no cell service, right? So they deploy these extra cells there. So in this case, we have a lighting controller on the top, and then inside the pole, this wireless revenue-grade power meter, so the utility can bill AT&T for the energy that it consumes. So again, another way to get data from the urban landscape, taking advantage of what you've got in place. And we've also developed a revenue-grade, transformer-rated EV charging station meter, and Pacific Gas and Electric plans to deploy 1,000 of these across their service area in 2018. What's nice about this is they can charge the individual customers. They're developing an app which says, okay, I know whether the space is available or not. So again, this sort of fosters economic development and another source of revenue for the utility. So if you look at Larry's slide and some other slides that were shown in some of the other presentations, there are really a lot of different type of applications that you can do. The problem that cities and utilities face, though, is that they've got these assets that are out there that are legacy, and so how do I instrument them and how do I get data back from them, particularly given the multitude of networks that can be out there. So this is something we thought of, and we actually have got a development going on which I'll describe to you. And in this development is if cities and utilities want to monitor the physical world, how do they deploy instrumentation, controls, and sensors like Curtis talked about out there on or near the streetlight pole and take advantage of that vertical infrastructure? Our friends at GE have an approach, our competitors at Cincity have an approach, and we've taken a slightly different approach than they. The utilities, if they're putting instrumentation on a streetlight pole, they want to be able to meter that, as we saw in the example of the small cell, and charge back to the customer, the resident on that pole. These sensors may need edge processing. If you deploy a lot of them across the urban landscape, how do you deploy and manage those devices, just like how do you deploy and manage cell phones if you're like AT&T or Verizon? You want these devices to be secure, and then you want to be able to provide communications back to cloud-based applications and platforms like Open Data Soft. Some other design considerations from the non-technical side are you want to make this thing affordable, deliver value today, and as smart cities evolve, deliver value in the future. You want to be able to leverage investments in the networks that utilities and cities already have in place. And a lot of cities and utilities want to be able to select the sensors and controls and instruments that they want to select. They don't want to be locked in to a set of solutions from one vendor. It's got to be ruggedized for outdoors and very portable. Had conversations with the city of Providence, Rhode Island. It's a working port. They've got a lot of renovation and urbanization, reurbanization initiatives going on downtown. It's close to Interstate 95, which is perpetually under construction. And so it's kind of like going to the Philadelphia airport years ago, right? So the whole idea for them was we'd like to be able to monitor air quality, but these air quality monitors aren't inexpensive. If we monitor a site and we correlate it to traffic or construction or the port, if we want to take that and move it someplace else, how can we do that? And back to the having choice, they'd like to have a partner ecosystem to work with. So we have developed this concept and brand we call the near sky. And the whole idea is that if you look at a city, you kind of want to colonize this space kind of somewhere below heaven, down to earth. Can you see it, the near sky? And it's really about like having sort of a data center on a pole, for sensors and for information processing. So if you look at data, how do you get it from the urban landscape? So we're talking about vehicles, public safety lighting, cameras, people themselves. We wanted to provide the ability to provide power, meter that power, edge processing, computing, measurement, and then move that to other applications and publish it. So this is sort of the approach. And this is a prototype. It's a little bit ugly. The final industrial design will be a lot prettier. But if you look at a normal street light, most of them have a 7-pin NEMA connector on top, and the street light controller or a photocell typically just plug into that. It's a really plug and rotate simple installation. So we've developed what we call the Near Sky 360 device. It's a module that has a single board computer in it. This particular version has AC power out. It also has a USB port, an RS-485 serial port, and 2 power over Ethernet ports and some digital IOs. So you basically can connect and support other devices that are on or near the pole. And depending upon, it also has Wi-Fi and Bluetooth in it. We're working on a cellular interconnection. So the whole idea is that we'll have a family of these, and the whole idea is that I can power and connect devices that are on or near the pole and talk to them, and then if it's a little bit of data, I can perhaps communicate that over the streetlight controller network. Or if I need higher bandwidth, I can use cellular, or if there's Wi-Fi, potentially that. So, to be determined what the final capabilities will be. So let me show you some examples of what we're thinking about here. So in this case, and you can see how it sandwiches on top of the streetlight controller, Bluetooth connection for parking sensors, some of which are in ground, Wi-Fi for phones, Zigbee, of course. Here, we're supporting on-the-pole cameras through power over Ethernet ports. This is something that a lot of our cities and utility customers are interested in doing, is being able to deploy cameras for traffic or public safety or just counting people for economic development. You heard from some of the Duke presentations, they'd like to be able to put digital media signage on the poles, so this is a really good way to do that. They could rent the pole out, provide their signage, and then meter the power from the. There's a revenue grade power meter in that thing also. So again, a lot of options, a lot of flexibility that can come from this device. So these are some of the use cases: network cameras, people counting, parking sensors, weather, air quality, etc. And we're using some AWS services to get data back to Near Sky View, which is a software platform, and then can publish to other applications, other platforms like OpenDataSoft, etc. So we think this is a pretty innovative approach. We're looking for pilot opportunities, so if any of you are cities or utilities would like to explore this, the design is not final, so this, we're really looking to figure out, okay, what are the use cases, what are the requirements technically, communications-wise and data-wise, and then can move forward on this. So again, it's how do you get data back from the city on assets that don't have a way to connect today. So again, lighting, many of us feel is really the gateway to a smart city, where you move from a dumb street light to a smart light pole with controls, put in this near sky capability, and then really start to generate new applications, new services, and potentially revenue from it. And I call your attention to a paper I authored on smart cities. It's on our website. And then if anybody would like to get in contact with me, here are my contact details. So thank you very much.